signal to the lovely Miss Mary Jane. I have a cheat sheet behind me, and or that I can stare at and sort of stay on track. For the last few weeks, Drew and I have been exploring the Ringmaster. Originally, when we said we were going to demonstrate this, we thought that this was a simple tool. It looked like a simple tool that we could explain to you in a single Sawdust session, and we were woefully wrong. It is a simple tool, yes, it is, but it is wonderfully versatile and capable of doing quite a few things. So, in this segment, what I'm going to show you is the basics on how to use the Ringmaster. And in doing so, I'm going to show you how to take a single board and turn it into a bowl. Let's take a look at what the Ringmaster is first, real quickly, and then I'll show you what it does. As you can see here, the Ringmaster mounts on the weight tubes of the Mark V. There is a carriage and a frame. The frame tilts 45 degrees to 0 degrees. In this frame are mounted two knives. I'm calling these knives uphill and downhill, and you'll see why when I start using it. The knives can be moved back and forth by turning the crank. Okay? If you angle the frame and move the knives back and forth while you're cutting a piece of wood, you will get an angled ring. These knives just slice that ring right off. Now, I'm going to move over here to the workbench, and I'll show you what you can do with those rings. Okay, these are rings that were cut on the Ringmaster. You stack them up like this, and they make bowls. This is a bowl that before it's turned, and these three bowls are what are the finished product. Now, depending on the thickness of the walls of the bowls, you may be able to do some shaping. This is a little cherry bowl that I made, and I'll bring this a little closer to the camera here. As you can see, it has a slight flare to it. I put a little concave curve in the sides, convex on the inside, so that it seems to flare out. The sides here were originally angled at 37.5 degrees. Okay, this is an oak bowl, beautiful piece of burl. Drew made this one, and he did the curving in exactly the opposite direction. It's got a convex curve on the outside, concave on the inside, so that it is shaped more like we think of bowls. Notice, by the way, on these bowls that the wood grain matches up. Because all of these rings were taken from the same board, they're all exactly the same color, and actually the grain tends to match from ring to ring to ring, so that in some cases, for example, let me go back to this cherry bowl. It's hard looking down the throat of that cherry bowl to even know that it is made out of rings. It looks like it's made out of a solid piece of wood. This is a bowl where we just left the sides straight. It's made out of sycamore. The walls were very thin to begin with, so we didn't do any curves at all. But as you can see, it's very nice and delicate all the same. That said, let's talk about how to make these rings. Okay, in order to glue up the rings one on top of the other like this, you need to be able to get the rings to fit. If you go to the first figure on the blackboard, you'll see some terminology that I'm going to use, and you'll also see what I mean by saying the rings must fit. By that I mean that if you have a ring here, the bottom surface must be the very same diameter inside and out as the top surface of the ring beneath it. And in order to do this, you need to pay attention to certain measurements and angles. First of all, when you're gluing up a bowl, you have slope. The wall, as measured from vertical, is sloped at a certain number of degrees. You have stock thickness. The stock is can be anywhere from a quarter inch on up to an inch thick. Beyond an inch thick, it gets difficult to deal with on the Ringmaster. But you have stock thickness. Finally, you have ring spacing. The rings will be spaced in from the diameter radially, and they must be spaced every so many fractions of an inch. The ring spacing, by the way, also controls the wall thickness, and the wall thickness is simply measured perpendicular to the slope of the wall. You obviously don't want to get the wall too thin, or you won't have room to turn the bowl. If you don't pay attention to these measurements, and the rings don't fit, you get something like this. Once again, I'll bring this up so you can see. There's bad steps in this bowl. See that? As I angle it, you can see those steps. The rings really don't fit. It's even easier to see it on the inside. However, you take a bowl like this, and look at that. Okay, this was done using just a little bit of math, you can see that math if you go to the second figure on the blackboard, which shows you a bit of trigonometry that we've come up with, and you can use these formulas to figure the slope, or S, the wall thickness, or WT, the ring spacing, RS, and the stock thickness, ST. If you don't want to do the trig, and I don't blame you, we've also put together an Excel calculator. If you scroll down on the blackboard, you'll find the Excel calculator is a downloadable file, and that you can, if you have an Excel spreadsheet to program, you can put on it. Even if you don't, you may be able to take a look at that and transfer it to your own spreadsheet for a calculator. Now, let me show you how to use all these calculations. Let's come back over here, and we're going to here being the Shopsmith, we're going to set up to cut a ring. This board is 3/4 of an inch thick. We want, for this particular exercise, we're going to cut a ring, rings at a slope of 40 degrees. Make a nice, really flared bowl. We need to figure our ring spacing. And if you look at the formula, the ring spacing is equal to the tangent of the slope times the thickness of the stock. So the tangent of 40 degrees is it's 8.839 times the thickness of the stock, which is 3/4 or 0.750. And if you multiply that out, you get a result close to 0.629, or 5/8 of an inch. So 5/8 of an inch is our ring spacing. We want to be able to move this carriage in with the frame 5/8 of an inch each time we cut a ring. Now let's get set up to cut. The first thing that we're going to do is we're going to center the Ringmaster underneath the stock and clamp it down. This requires a large Allen wrench. Okay. Now, because that's held in place with an Allen screw, and not only that, the Allen screw is set in a counter bore, it will fill up with sawdust in the course of a single ring. So here's your first tip. We're going to use this tape quite a bit today, but take a piece of tape and put it over the counter bore with that Allen screw. Believe me, that will save you some time. Now, would not be a sawdust session if I didn't drop something. Let's go to 40 degrees. I'm setting the slope here, and I will tighten this knob. There we go. Now, at 40 degrees, there is not enough room between the knives to put them over this 3/4 inch stock. As the frame turns and the knives get sideways, the distance between them, viewed at an angle, actually gets less. So what we're going to do is we're going to take out one knife. We're going to take out the downhill knife and just use the uphill knife. Now, I promised you I'd tell you why I call these uphill and downhill. When you're cutting your ring and you're cutting out away from the Mark V headstock, you're actually going uphill through the grain. This is actually causes the stock to chatter a little bit, and I try to make the uphill cuts first whenever I can, because the thing is more stable at that point. There's more stock holding the ring in. The downhill knife, of course, cuts towards the headstock and is cutting downhill on the grain, and there's a lot less chattering. The cut is a lot smoother. So, but we'll start with the uphill knife here. Put it in. Turn it and get it ready to go. Okay. Now, all we're doing now, we're not cutting a ring. We're just cutting the outside slope of this. Now, at the same time that I'm doing this, I'm going to take a 6-inch rule, and I'm going to tape this to, let's get my masking tape here. We're going to tape this to the back of the carriage, and the reason I am doing this is so that I can space the rings out. Okay, remember I told you I needed to move this carriage 5/8 of an inch each time. Okay, now I have got a something to read right there. That I've got the mark right on the 4-inch mark, and I will be able to move this carriage exactly 5/8 of an inch in, and lock it down again when it's time to cut the ring, and then I'll be able to move it another 5/8 and so on. I know that the Ringmaster comes with a space bar. Okay, they have a perforated bar here that you can drop pins in and space this thing backwards and forwards a precise 3/16 of an inch. The problem is that if you use this space bar, then all your ring spacing has to be 3/16 of an inch or a multiple thereof. You can't say move this thing in and out 27/64 if the trigonometry should call for it. I actually find it's much more versatile without this spacing bar. Okay. We're ready to make the first cut on the ring, let me put my glasses on. I'm going to take it. I don't remember what no, I didn't tighten that up. I'm going to tighten up the stock here, and let's go. I just turn the crank slowly. All right, that goes pretty fast. Now I'm going to search my apron pocket and find the downhill knife. Now, let's come in close on this knife if we can. I want to show you something about it that you need to know. There we go. See that? See how that knife is ground? It's sort of a Z-shaped. If you're cutting with this edge, the knife is closer to your. If you're cutting with this edge, it's farther away. You've got to remember how you position the uphill knife and position the downhill knife when you set it in the same way. Otherwise, they won't line up. So I'm going to put the downhill knife in first, and making sure, as I look down on this, that it's lined up with the uphill knife. First of all, I'm going to blow off any sawdust that might have gotten in there. Make sure that the knife is against the rear wall of the casting. Tighten the screws. These are 5/32 inch Allen screws, which is convenient. And now we're going to take out the uphill knife. And drop it into my apron pocket. Okay. One last thing before we do this. We're going to put some tape on the over the cut that we just made, so it straddles that kerf. If you've seen the Ringmaster video, you watch them cut this ring, and it breaks loose and just then chatters around on your machine. We did that a couple times here and decided that that was for the birds. The ring can break, for one thing. It can get jammed in the machine. For the other thing is that you get a smoother cut. If you just tape the ring in place. I'll show you why in a minute here. Moment, the ring is straight, and as you can see, it's not jumping around. Let's loosen this up. Back that out, slide the carriage back, and take this off. There you go. Now, to come in close, I want to show you something. Okay? Close, there we go. Look. See how smooth the inside of that ring is? Okay? There's a little tiny step where the two knives met. Okay? But you can barely see it. Now, if we had, hang on a minute, if we had cut the ring without the tape, okay, see that? It leaves a flange in there that you have to knock off later. That's a bad thing. Okay. Anyway, let's start now With the downhill ring or downhill knife, I'm going to. Okay, there it is, right there, lined up. That's where I cut it at. Now I'm going to take it 5/8 of an inch in and lock it down. And let's cut this ring free. You don't always have to remove one knife and replace it with the other, of course. If you're using a fairly shallow slope or a thin, where is that? There it is. If you're using a shallow slope or a thin piece of stock, you can leave both knives in and make the cut. But because this stock is so thick and the slope is so steep, we have to take one knife out and replace it with the other, or put the other one back in order to make each cut. Now, I'm going to take the ring in place, just put a couple of pieces of tape over the kerf. That's the other thing, too. You should realize that this tape trick may not work with two knives in the mounted in the frame. The knives may cut. One knife may cut through the tape. Okay, let's do it again. One ring. I'll cut just one more. We'll make a shallow bowl. And you don't want to sit here and watch me make rings all day, I'm sure. Okay, let me put that back on 5/8 and move that exactly 5/8 inch more. At a very slow speed. I've actually got the Mark V set to set to A. It doesn't take much speed to do this at all. There we go. Don't forget the tape. Just takes 2 or 3 pieces. I use 3 just to over-engineer. Once again, a nice clean cut here. And if we take our rings and take the bottom surface of the top ring and the top surface of the bottom ring, we will see, and there you go, look at that. Ah! Yeah. Okay. Getting closer, Mary Jane. Okay. There, see, you look at that. Look at that. That matches up perfectly, inside and out. Now, that's exactly how you want to do this. You also want to be able to match up the grain, by the way. And there's something that if the grain isn't as visible as it is here on this piece of maple, see, this is pretty easy to match up the grain and get it just right. But sometimes it can be harder to find. If you draw a line out from the axis of rotation out along your stock, you can then use that line to line up your stock as you glue it up. Let me take off the bottom. And we'll see how all 3 pieces align. This is a 1/2 inch hole, by the way. The arbor is 1/2 inch. There we go. Look at that. Absolute perfect. You know, the nice thing about using trigonometry, using a little math to get these things, is it really saves you time when you come to the turning part of this. It's much easier to turn something that lines up this well and not have to pare down all those protruding edges. Let me get. Speaking of turning, let's do a little turning on a bowl that I glued up previously. So because turning on this thing is a little bit different from what most of us are used to. The alignment with the axis of rotation is backwards from what a lot of us have been taught. By the way, this is why you put that tape over that Allen screw. It saves a lot of time when you're trying to to dismount this thing. Otherwise, you have to dig all that sawdust out of there. I learned that the hard way. Okay, let's put the Ringmaster over there. I'm going to step off camera real quick and get this bowl. You can use the same arbor to turn the bowl after it's been glued up. The problem you'll find, though, is that no matter how carefully you plan and figure and cut and glue up your rings, your turning is going to be slightly out of round when you turn it. So the first thing you're going to have to do is true up the turning itself. Now, first thing is that this needs to be scraped rather than actually cut. When you're turning this, you're going back and forth between long grain and end grain. The grain is running horizontally. Right now, as I've got this bowl oriented, the grain is running horizontally through the bowl. So if I had a scraper against here, I'd be scraping end grain, and then I'd be cutting long grain, end grain, long grain. It's really hard to keep a shearing tool lined up when something like that is happening. But the scraping goes very easily, as long as you also remember that, here, let me get a round nose scraper. If I have this round nose scraper does have a slight bevel to it. There is an edge here, and if I hold this against here, and my tool rest happens to be set below the axis of rotation, this will dig in as it cuts. And you see that? We get to the end grain here, and now it's really digging in. It's going to stick because the grain is running into the scraper. When that happens, this is the result. The bowl literally explodes on the Ringmaster. It's a shame too, because that was a nice piece of walnut burl. But maybe we can make half full. Okay, so you want, when you're scraping the inside of the bowl, you want to be above the axis of rotation. When you're scraping the outside of the bowl, you want to be below the axis of rotation. That way, as the bowl turns, you'll never be digging into the grain. You'll have some rough spots, as you can hear, but it won't dig in. As you can see, a nice sharp scraping tool like this is going to throw some nice wood curls. It's not like you're really buggering up the wood. In addition to the round nose scraper, I also reground askew and made a square nose scraper. This works pretty good. I've also found that these hollow form bowl turning things, which have nice little steel tips on here, they're kind of triangular. They work well also. What works especially for right before you do your sanding are just ordinary scrapers, metal cabinet scrapers, especially this egg-shaped scraper. You need, in order to support it correctly, you need to get the tool rest very close to the edge of the bowl. But once you do that, you can see it through the curls, and they really don't cut much smoother than that. So a combination of scraping tools, starting with scraping chisels and finishing up with the scrapers, seems to work real well on these. Of course, once you get it turned, there is one last thing that you have to do. The bowl, because of the way that you have to mount the stock on the Ringmaster, has a hole in the bottom. And this hole has to be plugged. Otherwise, of course, everything that you put in the bowl will run out. So what you need to do is get yourself, this is a 1/2 inch arbor, as I mentioned, and be right back with some 1/2 inch plugs, which we made with this plug cutter. You cut yourself some plugs from the same stock that you made the bowl from. Actually, you can, when you cut the circle, you can save the stock and make some plugs. This particular plug cutter, by the way, let's come up close on this. There we go. So just so you can see the plug cutter, this particular plug cutter, there we go, cuts a tapered plug. So when you plug this hole, okay, you have to put the plugs in, 2 plugs in, 1 from each side, and line up the grain. If you'll bear with me just a minute, I want to show you the bottom of this sycamore bowl. Drew plugged this. Want to come up to in close here? There. You can see. You can just barely see the plug there. If you're careful and you match the grain, you can plug this so you can't even see it. Anyway, that's the Ringmaster. Let's go back to the workbench for just a minute here. As I told you, the Ringmaster is remarkably versatile, and there's many other things that you can do with this. In a few weeks, not the next Sawdust session, but 1 or 2 after that, we're going to show you the next step in this process, and that is making segmented turnings. We're going to take triangles of wood with the grain running through this direction, horizontally to my hand here, this direction through the triangles, which will glue up to make wheels like this. Let me bring this in a little closer here so you can see it. Okay, you can see that'll have all sorts of possibilities when we turn that. Here's a segmented cherry burl that we're going to glue to a walnut burl, and we'll make some spectacular geometric turnings. Actually, the geometry is another part of the versatility of this Ringmaster. This is this bowl, which we haven't glued up yet. As you can see, this was made from a piece of wood where we just glued up walnut, cherry, walnut, cherry, walnut, cherry. And you can see, I guess there's some maple in there too, or sycamore, something in there. And you can see the stripes and that it gets. Beautiful stuff.
Well, I have mismarked my board. As you can see, I've used a pencil to mark my board. And now, seeing as how I've mismarked it, I'm going to have to get up the graphite. Well, instead of erasing it and embedding the graphite into the grain of the wood, I'm going to use denatured alcohol. Take a shop rag, get it wet with the denatured alcohol, and then just wipe away any of the bad nicks on your board. As you can see, he's gone.